Today we will do the scope and excitement of physics. The subject of physics has wide applications. It includes medical physics, where we use physics in medical science, computers, for example, when we study semiconductors in physics and we use that knowledge in computers, meteorology, material science, geophysics, engineering communications, environmental physics, and so on. Physics is a very exciting subject. It provides answers to many simple and exciting questions, such as why the sky is blue, also like why sunset is red, and also, for example, like why the atoms held together. Physics is exciting in many ways. To some people, the excitement comes from the elegance and universality of its basic theories, from the fact that a few basic concepts and laws can explain the phenomena covering a large range of magnitudes of physical quantities. To some others, the challenge in carrying out imaginative new experiments to unlock the secret of nature. So in both the cases, physics become excited to people. For example, because if you see in physics, we have only a few laws, and with the help of those few laws, we can explain so many natural phenomena in nature. And for example, also in the other hand, some people find interest in physics because with the help of physics, they can conduct an exciting experiment to unlock the secret of nature. Now, basically, there are two domains of interest in physics. There are two domains of interest in physics. These are, number one, macroscopic domain, and number two is microscopic domain. So the macroscopic domain includes the phenomenon which is happening in the laboratory, or for example also the terrestrial scales and other astronomical scales as well. So macroscopic domains are dealing with those, for example, when we conduct the experiment in the laboratory, or for example, let us say what is the happening in nature, terrestrial phenomena, and also at the same time astronomical scale. For example, when we study the stars and the universe and etc. etc. Now, on the other hand, the microscopic domains includes those who are like at the atomic and molecular, and let us say, for example, at the nuclear phenomena. So if we talk about the microscopic domains, we are dealing with the atomic and the subatomic particles. Now, physics is a vast subject. So physics, since it is a vast subject, it is divided into different branches. So branches of, I can write here, branches of physics. Branches of physics. Let us say number one, we classify this as classical physics. Classical physics. And inside the classical physics, we have the branches like mechanics, Number 2 is electrodynamics. Electrodynamics. Number C is, for example, optics. And number D is thermodynamics. Thermodynamics. These are the few branches of physics under the classical physics. Now we have also the second branches of physics, like what we call quantum mechanics. Quantum mechanics. Quantum mechanics. Now if we took the example of classical physics, for example like mechanics, it deals with macroscopic objects, with large objects that are moving at a speed smaller compared to the speed of light. So here in the case of mechanics, we will get or to deal with the ideas, for example like inertia, motion, force, energy, and so on. So it is dealing with macroscopic, let us say, objects. Now number B, it is electrodynamics. If we talk about electrodynamics, it is a branch of physics where we can study about electricity, magnetisms, or electromagnetic waves, or electromagnetic radiation. So in this, let us go electrodynamics. If I will repeat, it is a branch of physics that we can study, for example, electricity, magnetisms, electrodynamics, electromagnetics, electromagnetic waves, electromagnetic radiation, and so on. Now if we look at the optics, optics is a branch of physics where we are dealing with light and the phenomena which is related to light. For example, light, reflection, refraction, and so on. Now if we talk about thermodynamics, it deals with the study of the heat and its interaction with matter. So thermodynamics is a branch of physics which is dealing with heat and its interaction with matter. It includes the effect of temperature on the properties of material, heat flow, and transformation involving heat and work. Now if we look into the other branch of physics, that is quantum mechanics. Quantum mechanics, it deals with the behaviors of objects on the extremely small scale of subatomic or at atomic dimension. So quantum mechanics, we can say it is dealing with microscopic domains, because it is dealing with, for example, those objects which is very, very small in size, like at the atomic or at the subatomic level. Now, indeed, classical physics fails to explain the behavior of such microscopic material. If you look here about classical physics, they are failed to explain about the microscopic domains. But because of that reason, we have what we call quantum mechanics to explain whatever is happening in the case of microscopic domain. So with the help of these two main branches of physics, classical physics and quantum mechanics, that means we can say that they can explain every phenomena which is happening in nature. For example, for the macroscopic domain, we have the classical physics, and for the microscopic domain, we have the for the quantum mechanics or the microscopic domain, we have the quantum mechanics. So with this, we conclude the topic today. Thank you.